The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and FreedomSlips.com, its staff, or affiliates. You're listening to Revolution Radio, FreedomSlips.com, 100% listener-supported radio, and now we return you to your host.
Hey everyone, this is Dave from David Mackey's Shiny Side Out. You're back with us after the very small break, like I promised. And this is part 2, its second hour of Shiny Side Out with David Mackey on freedomslips.com. And this station has, or is, the number one listener-supported talk radio on the net. So we advise to continue that top position, that you push the donate button or subscribe to the archives. Yeah, I keep saying subscribe. You just enter the archives. You can become a Patreon and support the station by purchasing some merch, which is probably the best way to do it because you get something back directly. But if you like anything at all that either Mecky and I say, if we just simply entertain you, it's worth supporting the station. Now, Mecky and I don't get paid for this. As Mecky said, pro bono, for free.
More's the shame, more's the pity.
Well, that's what I tell him. No, kidding. All these years.
Is this why you're broadcasting from your Swiss chalet?
Yes. When I say dark and young country, I made the sign. I made a sign out the front of my chalet. Called Dark and Young Country. That's where I'm broadcasting from. That's so not even a thing. I live in rainy Narara. Today was really nice. I got a bit too much sun yesterday. I went to a car meet at Lakes Beach, and it was really nice. Probably 700 cars turned up there, and it was nice. It was good to get out. Get out and about and be in the sunshine. But there was, even so, it was only 18 degrees. Still got some of it. Just the sun is just crazy. It's off the charts hot. And in where we live, the UV light, you should really be very, very careful indeed with it. Don't play with it. It's dangerous. And so I'm going to get back to the thing. So get yourself some merch, some great merchandise from the station's website. You can get a t-shirt, a mug, or anything like. And it's all the art was done by Amad Painter, who's one of the hosts on the station as well. Now, Mecky and I have almost done 11 years on the station, and we really do appreciate the platform's existence. And we thank our late station owner for all his effort putting this together, and the admin team and production team getting this up and running and maintaining it, and all the wonderful hosts that you'll hear. An opinion which from everybody collectively that may get you thinking, may annoy you, and opinions that you may disagree with. But that is what messaging is all about. If you only hung with the people that echoed your same words, the same words that you think, but coming out of their mouths, if you hung out with those people, then you end up with something called confirmation bias, and you believe that to be the only true side of the conversation. Don't do that. Mickey and I don't do that. We like to, and it strengthens your position by hearing the counter argument if it has nothing. Yes? But if there is any information that you can glean from them, absorb that. Don't just throw it in the bin. I think it's really important. So Mecky and I, this is episode 548.
840 and 500.
It's the second hour, and we're talking about human-animal hybrids. And this is part 4 in the series, so you've got 3 to listen to before this one, if you want to catch up. So if you've accidentally fallen into this one, go back to the first one and then catch up and come back to this one again.
Look, we discussed a variety of chimeras, human-animal hybrids as they exist already. Other hybrids we discussed as well, and we also discussed the possibility that hybridization either already is with us or is just around the corner, which of course calls into question if all of those mythological creatures such as a minotaur or a satyr or such are in fact mythological creatures or not. Because if we can do it now, and we're very close to actually being able to do it, then an equally advanced civilization, or several before us, would equally have been able to dabble in this science and create these fabled creatures, of course, none of which seem to have survived into the modern day. But it seems that two countries are leading this kind of research, at least overtly. One is China, the other is Japan. Let's look at the Chinese efforts first. And this is an article that was published in 2019, September, by David Lawrence. And it's Genetic Engineering and Human-Animal Hybrids, How China is Leading a Global Split in Controversial Research. David Lawrence does not work for, consult, own shares in, or receive funding from any company or organization that would benefit from this article, and has disclosed no relevant affiliations beyond their academic appointment. That's important. It's a disclosure statement that you find on the beginning of most scientific texts. Now, back to the article. If you want to conduct groundbreaking but conscientious biological research, go to China. Last year, Chinese scientist He Jiankui announced he had created the world's first gene-edited human babies, shocking the world at a time when such practice is illegal in most leading scientific nations.
That would have been 2018.
2018, correct. Now that's 4 years ago now. More recently, US-based researcher Juan Carlos Ispizula Belmonte revealed he had produced the world's first human-monkey hybrid embryo in China to avoid legal issues in his adopted country. Yet if China is fast, I know, right? Yet if China is fast becoming the world capital of controversial science, it is not alone in producing it. More babies produced using the CRISPR gene editing technology are now planned by scientists in Russia, where another researcher is also hoping to conduct the world's first human head transplant. Now that's right out there. And Japan has recently lifted its own ban on human-animal hybrids, and that's something we look at in some detail here. The world is rapidly moving towards a two-tier system of cutting-edge medical research, broadly divided between countries with minimal regulation and those that refuse to allow anything but the earliest stages of this work. And that's really what the Japanese law was all about. The consequences of this split are likely to be significant, even potentially affecting your own access to healthcare. The births of the CRISPR babies in China led to uproar among the scientific community, which criticized He Jiankui and inspired calls for a halt in any CRISPR research on human embryos. In around 30 countries, and there are about 180 countries in the world, so it's not a majority. So in around 30 countries, which presents a small number of countries in the world as a group, gene editing of human embryos is already banned outright, or at least tightly controlled. For example, in the UK, only a handful of research groups have been granted a license to conduct experiments, and certainly not with any aim of bringing an embryo to term. This is really where the crux here is, right? But in most countries, things are less clear. The Chinese establishment was quick to condemn He's work and declare it illegal. And some commentators have made the point that despite outside perceptions, Chinese science is far from unregulated. Yet the fact remains that he was able to conduct the work unimpeded, with evidence suggesting he may have even received state funding. With the technology moving as quickly as CRISPR, many nations will not have had the time nor expertise to develop a comprehensive stance. That's really the issue here, right? Science, and this is not the only place where it does, but science is marching forward so fast, technology as well, that we can't really keep up with it from a I guess, point of view even. You know, what is our point of view? I don't know. What's the legal ramification? I don't know. Do we have any laws that are applicable? No, we don't. But do we do? I don't know. So as a result, it seems likely that we won't be able to avoid a two-tier system for this kind of research. Nations with developed regulation for biotechnology will be able to adapt more quickly and easily to the latest advances and put restrictions in place. Other states, which in my opinion will be a majority, will scramble to keep up, leaving scientists to proceed without having to consider the ethical or social implications of their work. or any other implications for that matter. And that's assuming all governments want to restrict this kind of research, which of course they may not. Dave?
Where are we? Oh, I see. We have seen what happens when there is this kind of international disconnect with other biotechnologies. Medical tourism has become a boom sector within the healthcare industry. People travel from all over the world to private clinics that provide, or claim to provide, stem cell therapies unavailable in their home countries. There have been high-profile cases of people traveling from the US to Mexico in order to skirt national laws and access mitochondrial replacement therapy. So it's safe to assume that those with the means to do so might try to access gene editing abroad when it's not available in their own countries, perhaps to avoid passing on a known hereditary condition that they carry. And with home DNA testing kits becoming widespread, although not necessarily accurate, the number of people wanting to edit their genome before having children is likely to increase. So for example, you might have a liver disorder, which is genetic, and you could modify that to no longer be a genetic disorder, fixing it, and therefore having children where you don't pass that disorder down. Very interesting. A lack or loose medical regulations also tends to produce predatory clinics that charge huge amounts for what sounds like wonder cures, but might be, at best, a sugar pill, or at worst, something actively harmful. And perhaps worst of all, regulatory problems might contribute to destroying the reputation of promising and developing medical technologies. The more nasty the incidents that are able to be attributed to an unregulated therapy, the less willing people will be to support legitimate medical trials of the same therapies. This kind of two-tier system of medical regulation could also lead techniques such as gene editing to become much more culturally accepted in some countries than others. Our society continues to struggle with xenophobia and racism, so we may also find prejudices and legal dilemmas developing from genetically engineered humans, never mind human-animal hybrids. Would people born using technologies such as CRISPR be allowed to visit or immigrate to countries where their very creation was illegal? Would it be illegal for them to have their own children and spread their genetically altered genome? This kind of conflict between international human rights legislation and domestic policy is yet to be tested, but could have grave consequences.
Sorry to interject, but it's really interesting that Gene Roddenberry in his Star Trek, mythology, had this very same thing at the heart of the eugenic wars, where the advanced humans were, obviously outpacing the regular humans to the point where it came to a war, and any kind of genetic interference in the human genome was completely and utterly outlawed by the Federation. Fascinating stuff.
Well, on to you. Worsening health inequality.
Oh, okay, very good. Okay, on the other side of the divide, if countries with strong regulations move too slowly to allow treatments that may be life-saving or disability preventing, it could worsen health inequality. We already have serious global problems with distributive justice, the ways in which services and technologies are only accessible to the privileged. It's like they listen to our show, Dave.
Yeah, that's right.
The problem is, if a particular illness could be prevented through CRISPR, is it right that someone should have to risk their child developing the disease just because they cannot afford to travel to a country where the technique is legal? I mean, this is the same thing that we're facing now with abortion rights in the States, right? I mean, what is the right answer? Is there a right answer?
Because you're doing it's the same thing as occurring. There's tourism now.
there's medical tourism. You're 100%
Yeah,
correct.
yeah.
Right, and it'll get worse as this goes on, because it means a slippery slope. What is the right answer? What is the right answer? Unfortunately, the obvious solution, internationally agreed standards and regulations, may be a pipe dream. We have consistently failed to find global consensus on gene editing issues, just as with embryo research. Even if it is possible to reach common ground, developing and implementing mutually acceptable terms that are flexible enough to handle the inevitable further technological progress will take many years. For now, though, proposals for concerted effort to keep track of gene editing research may be the best we can do. It is difficult to predict what could happen in the meantime, but it seems likely that more and more gene editing and other controversial practices will take place in a variety of regulated and unregulated circumstances. Sadly, it may be the case that little progress is made until the types of problems outlined above become all too real. And you know, Dave, I keep telling you the story of the bridges, the footbridges that go across busy roads.
Mm-hmm.
Each footbridge in Sydney, each footbridge that crosses a road, a busy road at a height, was built in response to someone dying there. In some cases, several someones dying there. Because we are not a proactive civilization, I don't think. I don't think we are. We are reactive across the board. Almost every country in the world operates like this, because there's always a cost associated. And guess what? Nobody wants to spend money unless they absolutely have to, unless it's on drugs. Everybody spends money on that, like there's no tomorrow. But unless something happens, okay, let's play this through there. Let's run some water through this little thing. So someone goes along and says, "Oh, look, you know, these children, we're going to help them, and they're going to have these benefits." And we okay, let's do that. Let's do that. So we do that. We change the genomes that might otherwise give them, you know, terrible diseases and conditions, and that's a good thing. That's a good thing. Then you go a bit further. Well, what about this? Well, you know, it would be really beneficial, right, if people glowed in the dark. It would be really helpful. You know, because you could save electricity, or you could easily find people down a mine shaft, you know, if they've got bioluminescence, or even, you know, underwater, etc. Now you could make argument for it. Okay, well, bioluminescence, okay, that sounds reasonable. Let's do that. Well, it'd be even better if we could somehow engineer gills into these people. Can we do that? Can we? And then if we do that, is it going to be an inheritable trait? Right? Do we actually alter their genetic material to the seed level, or not? Right, like Monsanto, for example, doesn't do that. Monsanto gives you a seed, but the seed can't germinate, or create other seeds, I should say. It germinates, but doesn't create more seeds coming from the fruit. So that's what they stopped. So should we do that here? So we're creating mules, in essence, right? Creating people, one generation of special abilities. And then you go further and further down that path. And then, oh, well, shouldn't we splice in more animal DNA? Because it'll make people stronger or faster.
Mm-hmm.
But then the question becomes, how much animal DNA or other DNA, or how much editing can we undergo before we are no longer human? Or do we now say, well, all of the editing that we undertake, including splicing of other species genes into our own genomes, is acceptable, and we can all be called human? You see, this is where it all falls apart, because at some point, right, you will have someone that's maybe 80% machine, right? But let's say pure human for the rest of it, and someone who's 80% I don't know, a chimpanzee, but 20% human with a human brain, etc. So which of these is the true human being? Are they both? Neither? What are their rights? What will be their children's rights? What happens to people that have such a mixed genome that, you know, if you were to analyze it, you couldn't clearly say that, well, this is now further away from the original human genome than even the great apes.
Right? Yeah, so, you know, 98.2%, right? What do you consider? What do you consider stretched away from humanity? Yeah. Yeah.
What if you're 80% away from the human genome, or 90% away? So there's only 10% left, but enough to classify or have the intelligence and brains, let's say, of a regular human. It's just the rest of your body is more modified than any other human before you, right? But your brain and your cognitive functions are the same. This is not easy stuff, Dave.
No.
This is. I don't think we can get there easily, right? But look, there's actually the actual situation is actually a lot worse. And if Dave, if you want to share with us what's happening in Japan.
Yeah, so there's a great story from October 2020. This is, during the pandemic. The new Japanese, and no one saw this, right? These stories came and went, whoosh. I thought, was that the wind blowing? No, that was the story landing that no one cared about, right? Just like disclosure.
Mm-hmm.
The new Japanese regulation on non-human chimeras. Should we worry? This is JBRA assisted reproduction. The author is Vera Raposo from the University of Coimbra. I'm going to say that. Okay, the abstract. In March 2019, Japan modified its norms regarding research with non-human chimeras. The amended rules allow the creation of chimeras with human brain cells and the subsequent transfer of the resulting creature to an uterus. I would say a uterus, where it can develop for more than 14 days, eventually until term. Wow. At this moment, the real consequences of this new regulation in actual research are still uncertain. However, many concerning issues have already been identified. This paper will start by addressing traditional topics involving this practice, the use of non-human animals in research, the use of human stem cells in scientific experimentation, and the creation of non-human chimeras. Subsequently, it will analyze the new concerning issues brought on by the 2019 amendment, the use of the human brain cells, the transfer of the chimera to a uterus, and its development for more than 14 days, and the possibility of using animals which present close similarities with humans. In the end, the paper will conclude that in spite of the legal and ethical hazards that this new regulation might carry, it should be allowed under strict scrutiny and not just let it run its course unsupervised. Number 3, here the point within the document. Problematic issues raised by the new Japanese regulation 3.1. The specified type of human cells used. The 2019 amendment came to allow the use of human brain cells to generate HNH chimeras, human non-human chimeras, eliminating the existing ban. This is not the first concerning incident in this regard. For instance, a study performed in the University of Rochester and reported in a 2013 Han and al. 2013 was able to create mice with human, I don't know how to pronounce that, GLIAL cells. Glial cells. That is thinking cells in their brains. I'd never heard that term before. Test results showed that the chimeric mice were much smarter than their peers. In the first half of 2019, a Chinese study involving human non-human chimeras created with brain cells was made public. Shi et al. 2019, Shi and Su 2019. Mackie, I have to just run off for a minute. I've got a terrible bleeding nose that just came about for no reason.
No worries, buddy.
I think they've turned the machine on.
That's not good.
Thank you.
You fix that, my friend.
My CIA handler needs to look after me a bit better.
The study involved the implantation of the human MCPH1 gene, a very relevant element for brain development, whose mutation can result in microencephaly, in 11 rhesus monkeys. The results showed that the brains of these chimeric monkeys presented some features similar to human brains in their development. For instance, better short-term memory and a longer time to develop, just like in humans. The main peril is the creation of animals with human brain functions and the hypothetical consequences this feature may have on animal behavior. In particular, the question is whether the introduction of human brain cells into the animal brain would grant them capacities considered exclusive human attributes. Accordingly, the British Academy of Medical Sciences concluded that the transplantation of human brain cells into animals in such a way that they adopt a human-like behavior should not be authorized. We still lack the answer for some basic scientific questions. For instance, how many brain cells would be necessary for an animal to develop human behaviors, and what kind of behaviors would those be? In the Rochester study quote above, researchers argued that there was nothing particularly human about these mice with human glial cells in their brains. This does not provide the animals with additional capabilities that could in any way be ascribed to or perceived as specifically human. Rather, the human cells are simply improving the efficiency of the mouse's own neural networks. It's still a mouse, and I'm quoting here Steve Goldman in Leuke 2015. We also ignore whether there's a specific moment in time when human brain cells must be introduced into NH embryos in order to achieve particular cognitive skills. The moment in which the human cells are introduced in the NH being is crucial for the subsequent development of the chimera. If it happens postnatally, the transferred cells will not substantially modify the animal structure. In contrast, if it happens during the fetal stage, and especially during the embryonic stage, the human cells will have the power to substantially shape the genomics of the animal. But we still ignore if particular consequences are connected with specific lapses of time. At this stage, we know that the introduction of human neural stem cells changes the brain of NH animals. But it is still unknown whether this is sufficient to make them develop the same skills as humans in what regards reasoning and self-consciousness. Some years ago, the British Academy of Medical Sciences stated that merely demonstrating quantitative enhancement of one aspect of an animal's cognitive function does not imply its cognitive capacity is approaching that of the human. Likewise, in a study, Huon 2016, stated that no matter how developed a HNH chimera's brain could become, it will never reach the level of self-consciousness characteristic of humans, as it takes several years to develop in infant brains that are 100% human and only under the right social nurturing conditions of child rearing. So let me just take a stop right here, and then Dave can take over. But this is, so let's be very clear. We don't know enough about brain development and child neural development at this point to categorically say that. It says here it takes several years in the infant brain. That is correct. But we don't know if a brain of an animal that has been injected with glial cells or had other genetic changes made to it wouldn't respond faster. Maybe it would respond faster. We don't know. We haven't done enough of the science, okay? So to say, oh, no, it won't be this and it won't be that, I think it's just avoiding the question of responsibility. Sorry, Dave, go on.
Nah, it's all right, because I've bred mice and rats, and very shortly after, on a scale which is not comparable to humans, say 3 years, only after a couple of weeks is the fully furry, non-pink little nubile plug walking around and doing the thing on its own. Like a foal is able to stand up and walk shortly after being born. I consider this question that's being posed here. Well, it's not alive long enough for us to determine whether it's self-aware or not, right? Or any significant change was made to the animal. And the next question is, so when can we find that out? having a paper that states that is surely making the leap for the next person that picks up the paper and goes, well, let's find out what does happen. What country can we get that done in? I think that's the most important thing. I mean, who knows? So, yeah. I looked at that's only the half of it. So, yes, but their accelerated, life cycle of only living for a few years anyway would mean that would become completely apparent. While there is education that occurs in mice and rats between like it handed down intelligence and a hierarchical structure within the group, which suggests that they possess already a level of communication and understanding of others with empathy, that they don't just go out for themselves. Does that make sense? I hope that makes sense.
Mm-hmm.
I studied them. I had them in my lounge room in a huge cage that was 6 foot tall, and I studied a community of rats to find out what they would do with new food sources, for instance. And if we were to experiment with them, I think that would be completely evident. I already saw them get the young ones finding a new food source and going and making contact with the eldest rat who had the most knowledge. They wouldn't eat it. They would say, hey, come down here, there's a new food source, and check it out, and you let us know. And then that would examine it and then be the most susceptible to if it was poison or a real food source. And it would then eat some, wait a while, and then advise the others they could eat it. Isn't that crazy? I didn't think that was a thing, but what they were able to have a hierarchy in their environment where that was a trusted source of information. That to me tells me a lot more about their society than what we thought ever happened. Yeah. Anyway, well, I'll keep reading. Hai-Un 2016 qualifies as anthropocentric arrogance, the belief that the mere existence of human brain cells into a non-human brain could magically make that animal human or quasi-human, even if higher cognitive capacities are not enough to require these enhanced chimeras to be treated as humans. They might still be able to change the moral status of these entities, and thus also its legal status. If the resulting chimera is considered human because indeed it has human cells, or even if it is merely granted a higher status than the one provided for non-human animals, the grounds, content, and purposes of research involving these creatures will have to be reassessed. In particular, a proper ethical and legal base for its elimination at the end of the research will be required. In the past, animals used in research were euthanized, but currently some of them, namely chimpanzees, are sent to sanctuaries to live the rest of their lives. Ultimately, it may involve recognition of dignity and some sort of legal rights to the chimera. Meki 3.2.
The transfer of the resulting chimera into a uterus and its development after the 14th day. The transfer of the resulting chimera into the uterus of an animal is a particularly problematic feature of the Japanese regulation. And then I abridged the text. The transfer of the chimeric being would not be so problematic if there were a temporal threshold. Until the last amendment, the Japanese regulation did not allow the chimeric embryo to develop for more than 14 days, which corresponds to a rule commonly accepted worldwide. This 14-day rule derives from the Warnock Report that forbids research in human embryos after the 14th day of existence, under the argument that before 14 days we cannot consider it to be an individual, because the primitive streak is not yet formed and an embryonic division is still possible. The two events, the 14th day and the primitive streak, happen almost simultaneously, and the 14th day is usually indicated as a decisive temporal moment precisely because of the primitive streak. Before the temporal threshold, the existing creature has no relevant moral or legal status, and it is not unlawful to use it in destructive scientific experiments. According to the British Academy of Medical Sciences, HNH chimeric embryos should not be allowed to develop beyond 14 days. Now, should is here the operative word, I think. Beyond 14 days of development or the first signs of primitive streak development, whichever comes first. Unless there is persuasive evidence that the fate of the implanted human cells will not lead to sensitive phenotypic changes in the developing fetus. Now, this is important now, the last bit here. Everybody listen very carefully. The revised Japanese regulation admits the development of the chimera after the 14th day limit in order to allow organs to develop. And eventually, it might be brought to term. However, we do not even know whether and how this chimeric embryo will develop. The transfer of the resulting chimera to an animal uterus and its eventual birth should not be totally banned, but it can be allowed, having in consideration the relevance of the aim, which in turn should be an aim of relevant importance, not achievable by other means. Now, if that didn't make much sense in English, you're not alone. What it means, because this is very much legalese, what it means is, if there's no other way for you to achieve a certain aim, a certain end, but to have this particular chimera go to term, then it's okay. Okay? It also must be important that the aim is important. Okay, so whatever your research is focusing on, the curing cancer, whatever it might be, right? It should be important. Now, all of the things I've just mentioned, the last paragraph, is completely arbitrary and extremely subjective. What's important to one person might not be important to another person. And to bind this legally is completely impossible. What the researchers will take away from this is this. I can carry a chimera to term. Because all I have to prove is that it's, number one, it is relevant.
Mm-hmm.
Yeah, it's important. Yeah. So it's important. And so first of all, my aim is important. Whatever I want to do in the end, that I have to prove it's important. Okay, so tick in a box. And then I also have to prove that the only way to get to my aim is to have the fetus carried to term. Those two things I have to prove. Right? And again, yeah, okay. Sounds important to me, Bob. Hey.
Next. So
Next.
What I think is interesting is that just the other month there was a lamb grown in an artificial uterus.
Yes.
So the conversation here that you're putting it into a host animal uterus, I think is really that's just what's the term for it not being relevant any longer?
Irrelevant?
Yeah, that's good. That's good. I was thinking more of like meaning it was old news. So
it's redundant.
Yeah, redundant. There you go. So that's where I believe where this conversation is at the moment. So we'll see. We'll see what happens in the future, because some of these conversations came out of 2011, 2000, 2017. And to see where that's going to go next is just crazy. I believe, Meki, that there will be someone who demands that their experiment go full term. One of the parts in this is that it says that it doesn't exhibit something rather human physically. So I thought that was extraordinary when I heard you say those words.
But see, this has now been signed into law.
That's right.
So this is the actual law.
Yeah.
Or the analysis of the law, I should say, right? And this is where we are. It's quite something to and again, I'm surprised. Or maybe not. I don't know. But the Japanese say, yeah, well, this is what it is. What, are you got a problem with that? What?
Well, I think it'll spread around the world anyway, and maybe that the what do we call it? The known subjects around the world will just do it anyway.
Oh yeah,
That's
Well,
what's
look,
going to happen.
once. See, this is the thing, though, right? And we've seen this before. Once something can be done,
Mm-hmm.
right, or we know it can be done, it will be done.
Mm-hmm.
And this is why we've now observed these and this is completely off topic, but we've observed these Tic Tac UFOs, for example, right?
Yeah.
Yes, there's more and more. Now, right now, we can't really duplicate what they do, or at least not officially, right? But because we know it can be done, there it is, you can see it, it means we will be able to do it because it can be done. So at some point in the future, we will be able to do it, right? So the thing is this, as soon as you know something is possible,
Mm-hmm.
you will achieve it. And I think that goes with most things. Right?
Oh, the room temperature,
crazy.
Meki, room temperature superconductor was created this week.
Yeah,
or announced this week. Yeah. And look,
It was nuts.
we have one story left. We've got 20 minutes, and I think we just let's burn through it, right? So, first monkey-human embryos reignite debate over hybrid animals. The chimeras lived up to 19 days, but some scientists questioned the need for such research. Some scientists, some say, right? Sounds like Top Gear. The 15th of April, 2021. Nidhi Sabaraman. This is a blastocyst of the, it looks like, right, of the monkey-human chimera. Credit to Weizhi Ji, Kunming University of Science and Technology. Scientists have successfully grown monkey embryos containing human cells for the first time. The latest milestone in a rapidly advancing field that has drawn ethical questions. In the work published 15th of April in Cell, the team injected monkey embryos with human stem cells and watched them develop. They observed human and monkey cells divide and grow together in a dish, with at least 3 embryos surviving to 19 days after fertilization. The overall message is that every embryo contained human cells that proliferate and differentiate to a different extent, says Juan Carlos Pizua Belmonte, a developmental biologist at the Salk Institute for Biological Studies in La Jolla, California, and one of the researchers who led the work. Researchers hope that some human-animal hybrids, known as chimeras, could provide better models in which to test drugs and be used to grow human organs for transplants. Yeah, sure. Members of this research team were the first to show in 2019 that they could grow monkey embryos in a dish for up to 20 days after fertilization. In 2017, they reported a series of other hybrids, pig embryos grown with human cells, cow embryos grown with human cells, and rat embryos grown with mouse cells. But the latest work has divided developmental biologists. Some question the need for such experiments using closely related primates. These animals are not likely to be used as model animals in the way that mice and rodents are. Non-human primates are protected by stricter research ethics rules than are rodents, and they worry such work will likely to stoke public opposition. There are much more sensible experiments in this area of chimeras as a source of organs and tissues, says Alfonso Martinez Arias, a developmental biologist at Pompeu Fabra University in Barcelona, Spain. Experiments with livestock animals, such as pigs and cows, are more promising and do not risk challenging ethical boundaries. Wow, good on you. If you were drinking milk from a cow-human hybrid, how would you feel? I think there's an ethical question there. Much more refreshed than that water with the electrolytes in it. There is a whole field of organoids which can hopefully do away with animal research. Meki.
Which brings us to a touchy subject. Is Pisua Belmonte, says that the team does not intend to implant any hybrid embryos into monkeys. Rather, the goal is to better understand how cells of different species communicate with each other in the embryo during its early growth phase. Sure. Attempts at growing human mouse hybrids are still preliminary, and chimeras need to be more effective and healthier before they can be useful. Yeah, let's make them stronger. Let's do that. Scientists suspect that such hybrids might have trouble thriving because the two species are evolutionarily distant. So the cells communicate through different means. But observing cellular crosstalk in monkey-human embryo chimeras, which involve two more closely related species, could suggest ways to improve the viability of future human mouse models, as Pisua Belmonte says. Well, that's good. Let's just do that.
Oh.
In the study, I know, right? In the study, researchers fertilized eggs extracted from cynomolgus monkeys, Maca fascicularis, and grew them in culture. 6 days after fertilization, the team injected 132 embryos with human extended pluripotent stem cells, which can grow into a range of cell types inside and outside an embryo. The embryos each developed unique combinations of human and monkey cells and deteriorated at varying rates. 11 days after fertilization, 91 were alive. This dropped to 12 embryos at day 17 and 3 embryos at day 19. But just a quick interjection. What it means, though, is that we have no idea how these stem cells will react with the monkey host cells. We don't know. I mean, what they said is there was a range of different things that happened, right? And the reaction was different in all of them. Some died, some lived. So we have no idea what's going to happen.
This test was only an on-off test.
Yeah, essentially. Right? Nothing was guided. Let's just inject it and see what happens.
Yeah.
Now, to go back to the text, this paper is a dramatic demonstration of the ability of human pluripotent stem cells to be incorporated into the embryos of cynomolgus monkey when introduced into the monkey blastocysts, says Magdalena Zernicka-Götz, a developmental biologist at the California Institute of Technology in Pasadena. She noted that this team, like others in the past, was not able to control which cells develop into which tissues, a key step to master before such models can be used. And that's my point really. Martinez Arias was not convinced by the results. I expect better evidence, especially of the later stages of development, he says. That embryo numbers rapidly plummeted as they approached day 15 of development suggests to him that the things are very sick. Well, fair enough. Combining human cells with closely related primate embryos prompts questions about the status and identity of the resulting hybrids. Some people may see that you're creating morally ambiguous entities there, says In-Soo Hyun, a bioethicist at Case Western Reserve University in Cleveland, Ohio. He says his team was thorough in following existing guidelines. I think they did quite a bit of due care, be mindful of regulations and ethical issues. Eh?
This is the research restrictions component of the story. Meanwhile, international guidelines are catching up to the field's advances. Next month, the International Society for Stem Cell Research, ISSCR, is expected to publish revised guidelines for stem cell research. These will address non-human primate and human chimeras, says Hyun, who is leading the ISSCR committee discussing chimeras. That group's guidelines currently prohibit researchers from letting human-animal chimeras mate. Also, the group recommends additional oversight when human cells could integrate with an animal's host developing central nervous system. Many countries, including the United States, the United Kingdom, and Japan, have at points limited research on chimeras involving human cells. Japan lifted its ban on experiments with animal embryos containing human cells in 2019 and began funding such work that year. In 2015, the US National Institute of Health, the NIH, which we all have learned to understand, announced a moratorium on federal funding for studies in which human cells could be injected into animal embryos. In 2016, the funding agency proposed lifting the ban, but restricting research to hybrids created after gastrulation, when the early nervous system begins to form. That might be the streaking part. More than 4 years later, the funding ban is still in place. An NIH spokesperson says the agency is awaiting the May ISSCR update to ensure our position reflects the input from the community, but did not provide a timeline for the release of the agency's rules.
And I haven't found anything on this at this point either, so I'm not sure that the rules have been released. In 2022. So except for the banning beyond the 14th day or the destruction, but not Japan. Not Japan. Japan is okay. You can do whatever you want in Japan. China, clearly, you can do what you want, even though it might be. It looks more regulated, when in actual fact it isn't.
Probably not. Yeah.
So I think I'm actually certain that we are looking at some very interesting times coming our way. I wonder, Dave, and this is really something I really wonder about. I wonder if these scientists believe it will be necessary for us to do this kind of research in order to maintain the viability of our species, especially after COVID and the vaccines, etc. I mean, what's going on? What aren't we being told? Why is this research all of a sudden? Yeah, that seems to be something we should be doing. Could it be that there's some event coming our way which will seriously question the viability of our own pure genomes?
That's a really good question, because look, I know that there's been some limitations about recreating the velociraptor, because chicken's the closest one. They wanted to make one and said that we've got the tech right now, we can do it. And I wonder if these limitations, Becky, because these timelines were the same timelines that the team working on reviving dinosaurs actually had the capabilities of doing it, but their legislation prevented them from doing it. I wonder if there's underground work going on right now, and that the creation of these publicly with funding needs to be corrected in order for them to proceed with those. Look at these are just questions. I know that once we've got any technique or capability at all, it's a free-for-all.
Oh, absolutely.
And so opening the gate by a millimeter still opens the gate.
Oh, 100%. There's nothing at all that would stop us from doing it. Once you can do it, then you do it. That's who we are. We can't help ourselves, right?
I mean, do you really only want to run faster or see in the dark, or do you know what I mean? You could change with CRISPR. You could change the color of your eyes with an injection.
That's correct.
That's as simple as it can get.
It's a bit nutty if you think about it, right?
Well, yeah, you could make your body produce HGH or anything else that you wanted. You could just turn on, living forever. You could just turn on your telomerase production, and voila, there you go.
Yeah.
Anything that you'd think would be a tick box on a check, like a query form at the hospital, just think about how simple it could be. If you wanted web toes because you're in a swimming competition this weekend,
yeah, that's right.
You could do that. You could make your feet grow really, really long.
Yeah.
You could do the AI thing, where the AI is asked to jump a bunch of obstacles on a 2D video game and get to the end as soon as possible. That's the goal. So it just made itself tall enough to fall in place with its feet still where it started. It falls and actually crosses the line. Because it made itself so tall it could fall across the front line. And that was the easiest way to do it. You could do whatever you wanted.
That'd be funny.
And I wonder how much of that is currently going on? Because if imagine you could become another person with enough change, you could go underground. Like we saw in the old spy movies where they take the bandages off someone who was said to have been dead, but they've changed their identity.
Mhm.
They had a facelift. What facelift? Who cares about that anymore? Just have an injection, and suddenly you've wiped 40 years off your life. Wow. I mean, these are what's going on, not the Chimera thing. So the Chimera thing, we could have all those animals we saw depicted in ancient Egypt.
That's true.
We could make a species of ourselves that become our overlords by mistake.
Yeah. Oh.
And that's the music. This is the end of another Dave and Mecky Shiny Side Out. This is episode 548, part 4 in a series. You should listen to the other 3. Coming up next is Jer Bear to sail you on to the morning, to the dawn, with his great show called After Hours. Stay tuned, become a part of it, dial in, and we'll catch you next week also for Plato's Cave on Tuesday and Thursday. We'll see you then.